Okay, so this next video you won't be able to answer the question immediately because it's to explain some new notation. What does x, and then this funny tilde, and then b, cap, open brackets, n comma p, close brackets, what does that mean? And then there's an example of it which we'll have to deal with as well. So, rather than give you a formal definition, I'm going to give you sort of the classic example where you would use this notation. Well, actually, we've seen it already. So, a coin with the probability of coming up heads is some number p is flipped n times. Okay, the number of heads is called x, so we count the number of heads. The number of heads is capital X. Then x is distributed binomially with n trials and p as probability of success. Okay? So I'll use those terms occasionally. The capital B stands for binomial, and we say that x is a binomial random variable. So I'll put that in red. So x is a binomial random variable. So this type of distribution, this is like a shorthand for one of those probability tables we saw in the earlier questions. And you can use a binomial one whenever you have something you're attempting a fixed number of times, n times, and you're counting how many times you succeed, and all the trials are independent and have a fixed probability of success. Okay, so let's just charge in and see whether we can understand the example. We've got x is distributed binomially with 6 trials and a probability of success 3/4. So to understand this second part of the question, we should be thinking biased coin comes up heads 3/4 of the time, is tossed 6 times, and we're asking about the total number of heads in those 6 coin flips. So what is the probability? I'll just write it again. So x is binomially distributed 6 trials, 3/4. And the probability that x equals 4, well, we've seen this kind of argument or this kind of discussion before. There are 6 coin tosses, and we must choose 4 of them to come up heads. That will count the number of ways we can get 4 heads. So that's 6 choose 4. And then for each of those possible sequences, the chance that heads comes up in exactly the correct places in the sequence is 3/4 to the 4th, and the chance that tails comes up in the right places is 1/4 to the 4th. So that comes out to be 6 choose 4, 6 factorial over 4 factorial, 2 factorial is 15, times 81 over, I guess, 256, times 1 over 16, and all of that comes out to, I guess you get 1215 over 4096 as that final probability. So that's a probability that would live in the table, in the probability distribution for x. The next question asks for the probability that capital X is less than or equal to 2. So this is something from the cumulative distribution, and what it means is the probability that x is 0 or 1 or 2. Now those events don't overlap, they're mutually exclusive, so we can write that as the probability that x is 0 plus the probability x equals 1 plus the probability x equals 2. Okay, and now we can work out each of those using an argument like we did above. No tails at all, so that's 6 choose 0, one way to put the tails in, times, no heads at all, so no successes, 6 failures, 1/4 to the 6th, plus 6 choose 1, place to put in our success, our heads outcome. The chance that head turns up in the correct place is 3/4, times 1/4 to the 5th for the other outcomes. And finally, 6 choose 2 ways to put in 2 successes, times 3/4 squared, times 1/4 to the 4th. Now, there's actually a common denominator of 1 over 4 to the power of 6. It's 1 over 4,096. So I'll take that out of the front. You get 1 times 1, or 1 times 1 to the 6, plus 6 choose 1 is just the number 6, times 3, times 1 to the 5, but I'll leave that. And then 6 choose 2 is 15, times 9, times 1, which I'll also leave. So adding that all together, you get 1 plus 18 is 19, plus 135 is 154. 154 over 4096. And that does actually simplify to 77 over 2048.